Okay, here's another modelling paper, Scout's Pace. It's from June 2017. It's the second part of the paper. I gave you the first part the other day, the virus part. So, Scout's Pace, 20 marks. You are advised to spend no more than 45 minutes. This task investigates a way of travelling long distances on foot using a mixture of walking and jogging. Number 1, explain why multiplying by 1000 over 60 changes kilometers an hour into meters per minute. Right, so this, I think just giving you 2 lines is a bit harsh, but it does seem to be a theme with these papers, unfortunately. I think they don't want you to write much. But basically, the 1000 is the conversion factor between meters and kilometers. So you know that 1 km equals 1000 meters. So basically, if I times by 1000, so times in by 1000 changes kilometers into meters. So that's the first bit. And then you have the 60 is to do with hours and minutes. So you know that 1 hour, and we're looking at kilometers an hour to meters per minute. So 1 hour equals 60 minutes. So basically, to turn hours into minutes, I times by 60, right? So you had on the bottom, what it is that you have got a speed which is in kilometers per hour. So you've got the number of kilometers divided by the number of hours. That gives you a speed in kilometers per hour, right? So if I want to change that to meters per minute, well, I'm going to do kilometers over, kilometers times 1000 over hours times 60. And that's why basically you have kilometers per hour times 1000 over 60. And as far as the mark scheme goes, really they're not looking for a really good explanation with lots of words. Basically, you need to say that I know that there's 1000 meters in a kilometer, and I know there's 60 minutes in an hour. And I think if you wrote that, it probably would be enough, but I'm trying to explain to you where it comes from. A scout walks 5 kilometers per hour. Show that 5 kilometers per hour is approximately 83.3 meters per minute. Now, you should always accept the hints that you are given. They've basically told you how they want to do it. It's often the case, yes, there are multiple ways to change kilometers an hour into meters per minute, but if they're hinting, or this is really the one you should be using, then do use that, because it's probably going to turn into a model later. So we need to just multiply it by 1000 over 60. So they're working out 5 times 1000 over 60. And if it's to show that, maybe we should show the rounding. So go to the calculator, 5 times 1000 over 60. And that gives us 250 over 3. Well, that gives us 83.333 ... So that's approximately 83.3 meters per minute. And that'll do. When walking at 5 kilometers an hour, the scout takes 120 paces in 1 minute. How many meters does the scout walk in 30 paces? Right, so we're going to use what we know about from the first 2 questions, really. So let's just write down what we've just been told. So we've been told 120 paces in 1 minute. And we want an answer for meters. So paces, minutes. So we don't actually have meters. So we're going to go back to something that had meters. Well, we've just worked out that's at this same speed of 5 kilometers an hour, you do 83.3 meters in 1 minute. Right, so if we equate 1 minute with 1 minute, it's going to be 83.3333 meters in 120 paces, because it tells me 83.3 meters in 1 minute, 120 paces in 1 minute, so it must be 83.3 meters in 120 paces. So if I want to know, well, in 30 paces, I can use direct proportion. To turn 120 into 30, I divide by 4, so I must do the same on the other side. Divide by 4. 83.333 divided by 4. Do use the ANS key whenever you can, or an exact number if that's better, or just a long decimal. You don't want to lose the accuracy marks. Divided by 4, and that gives us 125 over 6, which is 20.8333. So 20.8333 meters. I'm not going to do a lot of rounding in this, just I think these 0.33333s are probably more useful like that. If you want to call it 20.8, because you want to do 3 significant figures, you probably should, but I don't think you're going to lose the marks either way in this sort of paper. When jogging at 10 kilometers an hour, the Scout takes 150 paces in 1 minute. How many meters does the Scout jog in 30 paces? So we're going to use the same approach, but we're going to have to convert 10 kilometers an hour to meters per minute. Now you've got 2 ways to do that. You could either do the 1000 over 60, or you could recognize that 10 kilometers an hour is double 5 kilometers an hour, so we could just double this 83.3333. But I probably stick with the original. I will say 10 times 1000 over 60, and it should give us something 160-ish. 10 times 1000 over 60 gives us an answer of 166.66667, and that is a speed in meters in 1 minute. So we've got 1 minute. Okay, right, so we equate the thing again. There's 150 paces in 1 minute, and that's 166.66667 meters in 1 minute, so it must do 166.66667 meters in 150 paces. So if we want to know, well, in 30 paces, to turn 150 into 30, well, that's 5, so divide by 5 on this side, divide by 5 on that side, divide by 5, and that tells us 100 over 3, which is 33.333333 meters. So either write 33.33333 or 3 sig figs 33.3 meters. But remember, if I'm going to use these numbers in calculation, you want to use a fair bit of accuracy. I'd say 4 decimal places minimum, really. Right, what's next? Scout's pace means to walk for 30 paces, then to jog for 30 paces, and keep repeating this. Show that the Scout takes 27 seconds to walk 30 paces and then to jog 30 paces. Well, we're going to have to go back and find out about jogging pace and walking pace. So his walking pace is 120 paces in 1 minute, and his jogging is 150 in 1 minute. So walking, so that was 120 paces in 1 minute, and we're interested in seconds, so I'm going to call that 60 seconds. So that would mean 30 paces in, well, direct proportion again, 120 to 30, you divide by 4. Divide by 4 on the other side, that is 15 seconds. Use a calculator if you need to. That's walking. Jogging. That was 150 paces in 60 seconds, just confirm. 150 paces in 1 minute. 150 paces in 60 seconds, 1 minute. So 30 paces in, well, 150 to 30, that's 5s, divide by 5, 60 you need to divide by 5, and 5 12s are 60, but use the calculator if you need it. So that takes 12 seconds to jog 30 paces, 15 seconds to walk 30 paces. So to walk 30 and then to jog is the 27, but we need to show it. So I'm just going to write 15 plus 12 equals 27. There we go. Put it in the box just so it's clear. Find the average speed in meters per second of the Scout when using Scout's pace. So remember, Scout's pace is to walk 30 paces and then jog 30 paces. Well, you know, speed equals distance over time, and we want it in meters per second, so hopefully we can do number of meters divided by number of seconds, and that's all we should have to do. So we know that it takes 27 seconds, we've just worked it out, to do one cycle of Scout's pace. So at the bottom the time is going to be 27 seconds. For the distances, I think it's always worth looking back. I'm pretty sure we just worked those out. So number of meters the Scout walks in 30 paces was this 20.8, but used the long number. The number of meters the Scout jogs when doing Scout's pace, 30 paces, is 33.3, but use the long number. So we've got 20.833333 for walking, plus 33.33333. 20.83333 plus 33.3333 over 27. Go to your calculator. 20.83333 a few decimal places plus 33.33333 all over 27, and that gives us an average speed of 2.00617. So we will call that 2.01 meters per second. Right. Change your answer from part B into kilometers per hour. So right now we haven't been told anything that converts meters per second to kilometers an hour. It is in the main course, but I'll just show you how it happens. So if we have a speed in meters per second, so we have meters per second as a speed. We want to turn it into kilometers an hour. So what we're going to do, we need to turn the meters into kilometers and the seconds into hours. So you know that 1 km equals 1,000 meters. So to turn meters into kilometers, you need to go this way. You need to divide by 1,000. So this top bit is going to be meters divided by 1,000, right? For the seconds, well, seconds to hours, 1 hour equals, well, it's 60 minutes, and then there's 60 seconds in a minute. So it's 60 times 60 equals 60 squared seconds, or 3,600 seconds, a useful number to know. So to turn seconds into hours, you need to divide by 60 squared, or 3600. Okay, so we're going to have seconds divided by 3600. So what that ends up looking like is you end up with your meters over seconds. Or actually, let's just put it, if you think you're dividing by a fraction, so meters over 100. So that's meters over 100 times, remember, to divide by a fraction, you multiply by its reciprocal. So you multiply by 3600, that was 1,000, sorry, 3600 over S. So if you just rearrange that, you end up with meters per second times meters per second, which is the original speed, times 3600 over 1,000, which you could think of as 3.6. So actually this will always work. If you want to turn any speed from meters per second to kilometers an hour, if you times it by 3.6, that will do it. So what we need to do is take 2.00617 and times it by 3.6. I'll take the answer, times it by 3.6, and that gives us 7.22, lots of twos, 7.22 kilometers per hour. To find a model for average speed using Scout's pace, assume that at different speeds the Scout always takes 120 paces per minute when walking, 150 paces per minute when jogging. The Scout walks at X kilometers an hour and he jogs at Y kilometers an hour. Show that an expression for the distance travelled by the Scout when walking 30 paces is 25x over 6 meters. Okay, you've got two main choices really for this. You can convert the kilometers an hour to meters per minute and then find out how many minutes it takes to walk 30 paces if you walk 120 in 1 minute. The main advantage of that being that if say you'd made a mistake in the previous question with your converting to meters per second, then it won't hurt you as much because we already know from the beginning they told us how to convert kilometers an hour into meters per minute. So I think that's the main reason to do it that way. The alternative would be to, because you know from previous results that it takes, I think it was 15 seconds to walk 30 paces at this pace, and then you could just convert this X kilometers an hour to meters per second. To give the right answer, I'm going to lean towards the first one just because it relies less on getting everything right up to now. So we need to find the distance in meters, an expression for distance in meters when walking 30 paces. So remember, distance equals speed times time, and the units have got to be consistent. So I'm going to, you have a speed in meters per minute speed times the number of minutes. So if we do 120 paces in 1 min, that must be 30 paces in, well, it must be a quarter of a min. You just divide by 4, right? So it's quarter of a minute will be the time times 1/4. These meters per minute, well, we know X is the speed in kilometers an hour, and we have been told that to when you multiply by 1000 over 60, you turn kilometers an hour into meters per minute. So it's just X times 1000 over 60. X times 1000 over 60 times a quarter, right? So this is 1000x over, well, 60 times 4 is 240, and then you can just start to simplify it. And to be fair, you've got a calculator. You could probably just check if you just do 1000 over 240. Obviously, leave the x out, and it gives you 25 over 6 anyway. If you're not comfortable, you'll get communication marks. You might want to do something like this, so divide by 10, and you've got 100 over 24, so then you might say, I don't know, divide by 2, which would be 50 over 12, divide by 2 again, which would be 25 over 6. So either way equals 25x over 6. So that tells us how many meters you would travel when walking at a pace of x kilometers an hour if you did 30 paces. The distance travelled by the Scout when jogging is 10y over 3 meters. So they've just done exactly the same thing as we've done, but they've just used the y. So they've used 150 paces per minute. And possibly, if they use the same method, they work that out as 1/5 of a minute to do 30 paces at jogging pace. So it just saved you the job of doing this again because it's the same maths. Show that a model for average speed S in kilometers an hour using Scout's pace is S equals 5x plus 4y over 9. And we've got quite a lot of space for this, which suggests that it's going to be quite tough. So for speed, we know that speed is distance over time. S equals d over t. So the distances, which are 30 paces we have from A and B, we have two distances in meters and we already have a time in seconds. So we should be able to get an expression for a speed in meters per second quite easily, and then we're just going to have to change that into kilometers per hour, and I imagine there's going to be some quite hefty simplifying to do, but you would get marks just for seeing the initial bit, so I do think that's the way to go. So so in meters per second, the distance is going to be, well, it's the distance that we walk, which we've said in 30 paces, 25x over 6, 25x over 6, plus the distance that we jog in 30 paces, 10y over 3, over the amount of time this takes. Now we know from previous questions, to walk 30 paces and to jog 30 paces, it takes you 27 seconds. And that was a previous, that was something that was given. You see, there's a lot of show that's here, and yes, whilst they're quite difficult, at least it gives you a number that you could potentially use later on. So that's over 27. Now this will give you a speed in meters per second, right? But remember, meters per second to kilometers an hour. What you need to do, you need to take the meters and turn them into kilometers by dividing by 1,000, and then you need to take the seconds and turn them into hours by dividing by 60 squared. So you end up with meters over 1,000 times the reciprocal of s over 60 squared, so times 60 squared over s, which ends up being whatever your original speed in meters per second was, and then you times it by 60 squared over 1,000. Okay, so that's, I've already explained this in previous parts, but if you can get your head around this, it'll probably come up in a paper 4 at some point anywhere, or possibly a paper 2. They do like this meters per second to kilometers an hour. Right, so this would be a speed in meters per second, and then what we would have to do is flip that to kilometers an hour by doing this. So you would times it by 60 squared over 1,000. Right, so this is now our thing. I'm sure we'd get some marks just for seeing this, but now we're going to have to do quite a lot of work on it. And it's not really enough to go straight to this. It will go to this, but we're going to have to do a bit more than that. So if we take this initial fraction, so that would be, well, 3 times 7, 25 is 75, so 75x plus 10 times 6, 60y over 18, and then we're sort of doing over 27, so over 18, and times by, well, you kind of got 60 squared, or 3600, over, and I can just put the 27 in with the 1000, so 27 times 1000, which is still a bit messy, but so if you look at this, I think it's probably a good idea to attack this fraction here and just see, well, what is 3600 divided by 1000 divided by 27? So if we put that in, it might help quite a lot, and you can use a calculator for that, no problem. 3600 divided by 27 times 1000, and that comes out as 2 over 15. So if we call that 2 over 15, that should make things a lot easier. And actually, even looking at it, you can even say, well, look at that 18. You can cancel this 18 with the 2 and call that 1 and 9. And suddenly you've got 75x plus 60y over 9 times 1 over 15. Let me write that down. So it equals 75x plus 60y over 9 times 1 over 15. And now you can just look at this, the common factors of the top and the bottom, and there's a 15 will go into both of these. So we can just, so we're 75 divided by 15. Well, 4 15s are 60. So this is going to be, I can go 4, 5, and you end up with 5x, or s equals 5x plus 4y over 9, which is what we wanted. So I'm not necessarily suggesting this is the neatest way to do it, and I probably wasted a lot of space showing this again, which I wouldn't have done if I was just doing the paper and not explaining. But just remember, you don't necessarily have to be amazing at the fractions, because you have got the calculator at all times. So if this does happen and the numbers get quite big, your calculator will bail you out, and you don't have to show, you have to show some steps. You're definitely going to get some marks for there. And if you look at the mark scheme, I think it says you really need one more stage of simplifying, so I would definitely get it in here. And there's obviously more efficient ways to do it, there's less efficient ways to do it, but they should all get to the same place unless you make a fundamental error. Right, so part C, find the average speed using Scout's pace when the jogging speed y kilometers an hour is twice the walking speed x kilometers an hour. Give your answer in terms of x in its simplest form. Right, so actually if I consider this whole page, because all we're doing is using an equation and doing a bit of algebra on it, and actually the equation was given to us, so we're quite deep into this. We're very near the end of this modelling bit, and you've got we've got 3 questions, marks available, when you could have got everything wrong up to now and you still can get these marks, so it's quite friendly in that respect. So we're going to use this formula that was given to us. We had to show it, but it was given, and then we can use it. S equals 5x plus 4y over 9. Let's write that down. S equals 5x plus 4y over 9, right? And that gives us a speed in kilometers an hour, and everything here is in y kilometers an hour, x kilometers an hour. We don't have to mess about with units. It says find this average speed s when y is twice the walking speed x, so we can substitute y equals 2x. S is going to be 5x plus 4y for 2x, because y is 2x, over 9. Well, that is going to be 5x plus 8x over 9. 8x over 9, which must be s equals 13x over 9, which doesn't simplify. Over 9, done. Really quite a nice question, considering some of these have really not been easy at all. Find y in terms of x when the average speed is 1.5x kilometers an hour. So the average speed is the s bit, so this is 1.5x. So we're going to write 1.5x equals 5x plus 4y over 9. Right, so we need to find y in terms of x. So we're going to multiply by 9. 9 times 1.5. If you're not sure, it should be 13.5. But do try that again. 9 times 1.5 is 13.5. So it'll be 13.5x equals 5x plus 4y. So we've got to make y the subject, so you're going to subtract 5x from both sides. So 13.5x minus 5x is 8.5x equals 4y. So y must equal 8.5x over 4, which is not very nice actually. What you should never ever do is leave a fraction with a decimal in it. So the way we solve that is just multiply by 2 over 2. So 8.5 times 2 is 17. So y equals 17x over, and then 4 times 2 is 8. Right. The average speed is 7 kilometers an hour. The jogging speed is 10 kilometers an hour. Find the walking speed. So it gives us s and it gives us y. It doesn't give us x, so we need to solve for x. So s, we've been told, is 7. So 7 equals 5x plus 4y, 4 times 10, over 9, just like that. Multiply through by 9, 7 9s are 63, 63 equals 5x plus 40, 5x must equal 63, take away 40, which is 23, x must equal 23 over 5, you can go to your calculator or you can say it's 46 over 10, but it should give you an answer of 4.6. 4.6. So x equals 4.6 kilometers an hour. Number 5. The Scout now walks at 150 paces per minute and jogs at 180 paces per minute. Change the model in question 4b for the average speed using Scout's pace. Give your answer in the simplest form. Right, so the first thing we should do is look at 4b and see what we did there. So this was the model in 4b. Remember, it ended up being 5x plus 4y over 9. But how we got there, well, this 25x over 6 that was the distance. It's actually from 4a. It's the distance travelled in 30 paces at, it's when they are walking 120 paces per minute, and that was 25x over 6. So this is the distance travelled by walking 30 paces. This was the distance travelled by jogging 30 paces, and that was given to us, 10y over 3. This 27 here, remember, was the total time it takes to walk 30 paces and to jog 30 paces afterwards. So we'll have to do something with that. And this bit here was to convert. So this converted a speed in meters per second to a speed in kilometers per hour. Okay, so actually, if you think about the model, what's going to change and what's going to stay the same? Well, the walking pace, what we've been asked to do, the walking pace is now 150 paces per minute. So that is going to change the amount of time it takes to walk 30 paces, and it's also going to change the distance that involves. But it's not that bad, because if you look at it before, that's exactly the same speed that he was jogging before. So actually this 150 paces per minute that he was jogging, that was your y before, jogging at y. If you just literally take all the details for y and convert that to x, then that shouldn't be too bad at all. So when he was jogging 30 paces, that gave us a distance of 10y over 3. So that's going to turn into 10x over 3 if he jogs at the same pace. So if he walks at the same pace that he was jogging at before. So we're going to have a 10x over 3. That's going to be the distance that he walks in 30 paces at the speed of 150 paces per minute. Right? And then the time also, we should be able to use the time that we had before. So if we just go back a little bit, when he was jogging at this 150 paces rate, we actually worked that out, that it would take 12 seconds to do 30 paces. So we've already done the work for that. So we can use this 12-second number as well for the x, because he's walking at the speed that he used to jog at. Right, so this walking time is going to take 12 seconds, right? So, but unfortunately, we are going to have to, we've got this new pace of 180, and we're going to have to do the working out for that. So if we look at what we did before, well, we worked out the distance, and we used the conversion of, we did it in meters per minute times the number of minutes. Right, so we're going to have to work out how long this takes in seconds and how long it takes in minutes. I'm going to use both of those numbers, because I'm going to still use this bit that we were given right at the start, which tells us how to convert kilometers an hour, which is what the speeds are given in, to meters per minute. So I'm going to times by 1,000 over 60, sorry. So if we think about y, we have 180 paces in 1 minute. So to do 30 paces, well, that's divided by 6. It's going to take 1/6 of a minute. Okay, so 1/6 of a minute. And actually, I might as well, because I'm going to use it, 30 paces, or 1/6 of a minute. 1/6 of 60 is just 10 seconds. 10 seconds. So actually, this the time it takes to jog 30 paces, if you do 180 paces in 60 seconds, it takes 10 seconds. So I've already got the denominator of this fraction, some of it. Then we need to work out this other bit. So what we need to do now is work out the actual distance that you're going to, at speed y, the distance that you're going to do in 30 paces. So we'll use the same methods from number 4. So it is the speed times the factor that converts it into meters per minute times the number of minutes. So it's going to be y is the speed, y, times 1000 over 60, given to us right at the beginning of the paper, times the number of minutes. Remember, this is just speed times time. So it's speed, and this really is all speed, because this is just a conversion. It flips it to meters per minute. This is speed times time. The time is 1/6 of a minute, 1/6. Okay, so basically, if for the y, you're going to have y times 1000 over 50 times 6 is 360. And you can just go to your calculator and you can do 1000 over 360, and that gives us 25 over 9. So now we have 25y over 9. Right, so that can go in here, 25y over 9. So now if I compare it to the method used in 4b, or the model that we arrived at in 4b. So we've got the we've got this, we've got the time. We just need to put this in, which will not change, because all this does is converts the thing to kilometers per hour. Remember, this is the number of meters total divided by the number of seconds. So then we need to have this times 60 squared over 1000. So that is the calculation. I'll put a box around that so it doesn't get confused. And then we just need to do some next steps and end up with an answer here. We don't necessarily need to do everything. But okay, same as before, I'm going to at least show the adding of these fractions, and I'm going to definitely simplify that. So we have, if I go over here, this is 10x over 3 plus 25y over 9. So that's a common denominator of 9. So if I just times this by 3 over 3, that would be 30x over 9. So you've got 30x plus 25y over 9. So that's this bit here. Over, in fact, I'm even going to pull this 27 here. So times 60 squared over 1000 times 22, 22 times 1000. Right, so what is 60 squared times 22 over 1000? Go to the calculator. 60 squared over 22 times 1000. So that is 9 over 55. So you now have equals 30x plus 25y times 9 over 55, and that was over 9. So the first thing you see, look, the 9s you can cancel. 9, 9, 1, 1. So now you just have 30x over 55 plus 25y over 55. 30x plus 25y over 55. And so the best way I would think to do that is put 30 over 55 into your calculator, or you might just see that 5s are the common factor, I suppose. So it is 5s. You got 5 as a common factor in all three terms. 5, if we divide all of these by 5, 5 6s are 30, 5 5s are 25, and 5 11s. So you end up with 6x plus 5y over 11, and that's what will go in here. 6x plus 5y over 11. and that is S equals. So this is, I would say, quite a challenging paper. You'd be a bit unlucky, I think, if you got this. But if you think of the investigation bit that went with it, that was quite generous. So I suppose overall, you might say it's a fair paper. But at the very least, I think just preparing for it and using it like this, it should strengthen some of your distance, speed, time work, which should help a lot. What I find interesting about it is we didn't have to plot a single graph, which is very rare for a modelling paper.